Okay. Guys.
Hi. Nick and I wanted to, well, Nick's going to explain some things to me, and I thought it would be a good idea to get some video of it and kind of be a teaching moment for me and then also you guys.
So guys, Maddy was asking some questions about when we were ordering parts last night. I take that back. We didn't order a damn thing. But we were kind of window shopping, okay? We were going through some different websites and stuff like that, and she was asking a bunch of questions. So I figured it might be kind of beneficial to go through and do a little video and explain some things. I know some of you guys don't plan on building a motor. I know some of you guys don't want to get into this much depth about things, but like...
There's also people that already know and don't need to watch
exactly
necessarily this for any kind of educational aspect, but...
But for us, like, we do just about everything ourselves. I build my own motors. Jansen does the machine work and stuff like that on that. A, I'm not capable of it. B, I don't have the equipment to do it. I do a little bit of machining here and there, and I'd like to find a mill and a lathe eventually, sooner than later. But at the same time, we can't just go fork out $6,000-7,000 on a mill and $7,000 on a lathe just to use for the little things that we need to do. But getting back to what we're doing, we're basically mapping out some different pieces for the trip flow block that we picked up for the wagon. We need to find a name for that thing too. But we're planning on that, and we're talking about some other things like a bolt through center section. We've only ran bolt through center sections, so Maddy wasn't fully understandable of what the bolt through case was. I guess we could pick that up. We'll go in the trailer and grab Donnie's one, and we'll add that to the end of this video so we could explain that as well. But here's just a crankshaft, rod and piston combo, and a blank piston. Okay, so we're going to talk to you about a little bit of different terms and so on and so forth. Okay, I guess we're going to start with the crankshaft. Want to start with the crankshaft?
Sure.
Okay, we'll start with the crankshaft. Okay, so guys, these right here, boom, 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 and boom. Okay, those guys right there are the main journals. Okay, on a big block Chevy, there's a little bit of issues with the big block Chevy. Nothing
catastrophic.
Nothing catastrophic. Just like different things. Like an LS motor, I believe the thrust bearing is in the middle. There's no. It just took me a second. I'm a dumbass. So the thrust bearing's in the middle. Here, you set the thrust off of this guy here. The rear main cap goes here. You got that extra large bearing there, and you got this piece right here that sets the thrust on the motor. Okay. So believe it or not, you put the crank in there, and to set your thrust, you put a block of wood or something like that on the snout or a good rubber hammer, and boom, whack it. And then you move it back and forth until you get your proper tolerance. I'm not going to say the number because I'm not going to be whatever. I do it my way. You do it your way, so on and so forth. I'm not here to give engine building tips. I'm just going to explain things for you. So, this right here is a two-piece rear main seal crankshaft. A one-piece rear main seal crankshaft has like a lip that's probably about 3/4 inches wide, and it goes all the way around. And that's how it seals. A two-piece rear main seal goes through there, and it's two pieces. And when I put them in, I don't put them in line with the main cap. I offset them a little bit so that the cracks of the rear main, since the seal is the same size as the main cap and the size of the block, I offset them slightly and put just a dab of RTV on them. And so when you set them in, there's not a straight line going from the main cap to the block, or main cap, how do I say that? Straight line basically through the seal and everything. Basically it has to offset. If there's oil or anything gonna come out, it has to offset and find another crack and find the seal down there. Okay, so
when we're building the engine, putting it together, we will do more video.
Yeah, I'll explain that.
Yeah,
a little bit.
It'll come back around. But basically, you've got the two pieces that come together when you put the seal on the inside of that.
Yeah, it's just two halves like this, kind of like a rod cap, I guess you could say. Okay, so let's say your block is this and your main cap is here. Okay, instead of putting my seal, so the two pieces go here and here, I offset it this way.
Yeah.
So that this line doesn't go straight through. It comes up and down and offsets a little bit just to make it a little bit more difficult for any oil or something to come out of the rear main seal. Okay, on a typical big block Chevy, like when we were looking at rods and stuff like that, the rods, she's like, why is there like different size rod journals? What is this number? Well, typically, it's a 2.200 rod journal. Okay, some rod journals are a little bit smaller, some ones are a little bit bigger. Standard is generally around 2.200.
The width? Or
The diameter here.
Okay.
All right, for the rod journal, the piece that goes in here.
Okay.
Now, when you turn a crank or something like that, you need to get oversized or undersized bearings to fit that rod journal. But specifically made crankshafts might have a Hemi rod journal. They might have a small block rod journal. That's getting into more aftermarket stuff, more expensive stuff. They have their benefits, but it's also more money. So standard rod journal is about 2.200, and then you could turn them down. On the mains, if I remember properly, it's like 2 3/4 inches. I have to double check that, but it's right around 2 3/4 inches for the mains. Okay, those can also be turned down. You take it to a machine shop, and they'll turn these down to make it so it's perfectly smooth. Okay, this thing will spin up to, if you're shifting at 9,000 RPM, that means this guy is spinning 9,000 revolutions per minute. Okay, which is freaking fast. Okay, when you measure the stroke on a crankshaft, the stroke is the difference between the main journal and the rod journal. Okay, if you had a 5-inch stroke, this guy would be out here. If you had a 1-inch stroke, this guy would be back here. Okay, there's no such thing as a 1-inch stroke unless you're in like a Briggs and Stratton or something like that. A little 5-horse go-kart motor. Those probably even have longer than a 1-inch stroke. I don't know. But the stroke is the difference between the main journal and the rod journal. Okay, when you turn down a crankshaft, generally we don't want to run anything turned over about 20 thousandths. Okay, which means from factory they turn them down 20 thousandths. They shave off 20 thousandths of this diameter. Okay, the crankshafts that we all run go through like a heat treating process and like a hardening process. The hardness only goes so deep into the metal. So when you go over about 20 thousandths thick, you start making the crankshaft a little bit weaker. Okay, because the hardness of the crankshaft, it doesn't impede into the core of the material. So that's that. Then we could go into a whole lot more. You know what we could do? This is no. Why don't you change the camera real quick?
So the difference between a cast and a billet crank.
Or a steel crank, forged crank.
Cast or steel. One goes ting and one goes tang.
No, one goes
Ting.
dong.
Oh.
One goes dong.
Dong. Yeah. I forgot. You want me to pick it up?
Well, you can pick it up, but don't pick it up. Just grab something and whack it.
Like this?
Give something a little more meaty than that.
This?
Yeah, that works. Explain to them what you're doing.
Well, I don't remember how it works, but the vibrations that run through it after you smack it a little bit, right?
Mm-hmm.
With an object, it rings a certain way, just like a wind chime when they clang up against each other. So one will tell you if it's the difference in the sound will tell you if it's cast or steel
or broke.
Yeah, that too, I guess.
So
if it's broken, it won't sound won't travel.
So guys, Maddy's gonna basically show you a way that you can field test a crankshaft, or if you're going to go purchase a crankshaft and you don't have the part numbers of the crankshaft to know if it's cast or steel, I'll show you another way to do it. But I'll tell you, there's a parting line right here. A skinny parting line generally means it's cast. Okay, fat parting line means it's forged. Cast cranks are basically junk. They won't last for nothing. We'd break them in a pass or two. Good forged crank, quality GM forged crank, you can make some decent power with them. They're not a good Crowder crank. They're not a good Cayley's crank. They're not a good Lunati or Bryant or so on and so forth. They're just not a high-end, good quality crank like that. But a good factory GM nitrated cross-drilled crank, they're pretty good quality. So that's what one of these is. Go on and give it a whack.
Here.
So I don't know if you guys could hear that or not, but like they ring pretty good. So, and you can see how it like the sound goes throughout its way. So if we're racing or something like that, and we suspect that we have a broken crank, we could drop the crank out of the motor, and you could whack it, okay? And the sound should ding, and it should resonate for a while, okay? If it was a cast crank, it'll just go boom, like it doesn't. It's a weird.
Like the dome. What are those?
Yeah.
What is it?
A Gambia or something like that.
I don't know.
Gambrel? No.
No.
I don't know. A Mongolian bong. Okay. So guys, that's a little bit of info on the crankshaft. There's also single keyways and double keyways and so on and so forth, and we go on and on and on. There's also the amount of the throws on the crankshaft is all different. This one's got 1, 2, 3, 4, 5. That one's got 6. They got all different quantities and so on and so forth. Okay. Want to bring the camera back over here and we'll talk about pistons?
Of the crank.
Okay, guys. So here's our piston. This is a spare piston that we travel with.
The one from the laundry basket.
The one from the laundry basket that's been falling along. I don't know how in depth I want to get about this. Basic. Okay. So basically, guys, this one has a small dome on it. I actually measured it. This is about a 14cc dome. I did a video on the Hustlin' Horsepower channel that goes and talks about all that. Also, this one has a pin height of 1.45, compression height, they call that. This one has, if you can see in here, there's no grooves cut in here. So this uses like a floating style pin or a floating style kisser button. Maybe that's not the real name for it. I call them kisser buttons. There's a little piece of aluminum in here and they got a flat side on them. Since you can see that this oil ring land is not supported here, the kisser button goes in there and gives it a little bit of support there. Okay. In a turbo blower application, we want this upper ring land at least 200 thousandths down, because this right here sees a lot of force on it, and you could actually pinch the ring lands. And when you pinch the ring land, it's only a matter of time until you blow up your stuff, because you'll get oil in the cylinders, and oil just causes detonation and boom and bang and no good stuff. Okay, so all big block Chevys basically run a three ring pack. This is like your compression ring. This is an oil scraper, and this like helps seal the oil, bringing it down. Oil, whatever the hell you want to call it. But I generally, when I make them, I set the top and the second one at about the same gap, and you orientate them in the proper way so they seal properly. Similar, I guess you could say, to the way we do the rear main seal. You don't want to have all the ring lands in the same orientation, because then, you know, you'd have a streak of oil going up and down. Okay. This is the pin size, the pin diameter. This one's 1.100, and this one's a 990 pin. Okay. Generally speaking, steel rod will have a 990 pin. Yeah, a steel rod will generally have a 990 pin in it for a big block Chevy. You could see in here, these ones have things called spiral locks. So there's a groove cut in there. Can they see it? Yeah. These ones have a groove cut in there, and there's spiral locks in there so that the wrist pin can't come out. Okay, you can see that this guy's moves freely in here, but there's no slop in it. Okay. The pin will also move back and forth a couple of thousandths with the spiral locks in there. But you can see on this piston that it is encapsulated 360 degrees. So you can use a spiral lock in it. This one here is not 360 degrees. It goes into the ring land. Okay. So on these ring packages, it's about a 16th, and 3/16. You could run a different ring package. They make pistons with a lot smaller rings with lower tension on them. If you're running like let's say a naturally aspirated application, no turbo, no boost, no nitrous, you could run this ringland up a lot higher because you don't have as much cylinder pressure in there. You can move everything in the piston because it makes it, it does make it a little bit weaker, but if you're not putting boost or nitrous to it, you don't really have to worry about this collapsing and pinching ringlands like that. But if you do have a piston like that and you want to throw 250, 300 horses worth of nitrous on it, you're going to pinch a ringland and you're going to start breaking rings. It just is what it is. So we choose to run all billet steel rods. Get in the video.
Because I'm making sure that you don't get too far forward.
Well, I can get real far forward if I want to.
In the camera. Jackwagon.
Okay, so we run all billet steel rods. Billet steel, we'd love to run aluminum, but aluminum rods, they just simply cost too much money to replace every... Nowadays, you got to replace them a whole lot faster than you used to. So
in our application, you would have to replace it like every 40 passes to be
46 passes, so you don't freaking break a rod in half. But that's just the difficulty with Corona and stuff like that. And I personally believe that the quality of material going into them is changing because of the delays and stuff like that. Okay, so we could go in more in depth when we start assembling a motor, but we choose to run all billet steel rods. We have several manufacturers of rods that we run. It just is what it is. A lot of them are secondhand. A good steel or titanium rod, if it's not broke, it's generally good. Aluminum rods will stretch. They just do. They stretch, and they'll stretch and then they break. So generally you shouldn't have to check the length of the rod at all different times. But the length of the rod goes from the center of the pin to the center of the rod cap. These things are perfectly circle, but when you order rings or bearings, the bearings are actually like egg shaped to a certain point. So when you crunch it down, it helps hold it so it doesn't spin. When you assemble one, you do tang to tang. That goes with all caps, main caps, rod caps, so on and so forth. You can see the two tangs in there, hopefully, maybe. It goes tang to tang, and that helps seal the, hold the bearing in place and stuff like that. What else? I don't know. That's probably about good, right? But yeah, she was asking about like the rod journal size on here. These are for a 200 rod journal. And then like I said, you'll get oversized bearings and stuff like that to fit crankshaft if it was turned or something like that. Most of them. These are flat tops. This is probably about what the I think these ones make about 9.5 or 10 to 1 with a flat top with just a small valve relief in it. And also, you can see the one side of the rod is chamfered. What else? Yeah, chamfer goes to the outside of the fillet. So this would be over here. You know what? Let's not go get that other one. We can just tell them.
Center section?
Yeah, so like a center section. Okay, so like we run all 9-inch rear ends. We're also looking for a jig so that I could shorten up my rear ends and change the length on my rear ends. I usually just borrow one, but I'd like to have one of for myself. But a bolt-through case is different than a non-bolt-through case, because a bolt-through case, the bolt actually goes from outside the case, through the case, and into the main cap that holds your spool. So a non-bolt-through case, it actually goes inside, essentially, inside through the main cap, and then it threads into the case. It's just a little bit stronger to run a bolt-through case since it attaches to the main cap and not to the case.
And where the yoke is, it has those 3 bolts.
4.
On the case. 4? There's 4? Okay.
Yeah, there's 4. We got 2 main caps with 2 bolts for each.
Okay.